I'm going to start off the talk with going through the Lake Trout Working Group report, and I'll move into his presentation on lake trout rehabilitation. First, I'd like to acknowledge all the members of the Lake Trout Working Group on Lake Michigan. As you can see here, it's a lot of different folks from a number of different agencies, all compiling data, doing different things, and submitting that to put into the results of the Lake Trout Working Group reports. The purpose of the report is to have comparable measures of a number of different metrics and use to gauge those current values against historic values and use those to gauge lake trout restoration in Lake Michigan as outlined in the 2008 Guide to Rehabilitation by a number of folks in this room. The first objective, as a lot of folks have seen these before, is to increase the genetic diversity of lake trout by introducing morphotypes adapted to survive and reproduce in the deep water offshore habitats of Lake Michigan while continuing to stock the lean forms that we historically stocked. This is to utilize the habitat that is being underutilized by the strains that have been stocked in the past. Recently, the Klondike Reef strain from Lake Superior was selected and cultured for introduction into the deeper water habitats of Lake Michigan. In 2012, these Klondike Reef fish were stocked off of the Northeast Reef down by the Mid-Lake Refuge off of Milwaukee. We continue to stock Seneca Lake, Lake Superior Apostle Islands, and Lewis Lake strains as the primary lean lake trout form in Lake Superior, utilizing the shallower water habitats. And in addition to this, there was a movement to introduce the Perry Sound strain from Lake Huron, and the broodstock for that were cultured, and those are set to go into the lake later this spring. A number of fall fingerlings were actually stocked last fall in 2012 into the Wisconsin waters of Lake Michigan. Objective 2 is to, by 2014, increase the densities of lake trout populations in the targeted rehabilitation areas to those levels observed in other Great Lakes areas where lake trout are doing well. To do this, they've set a metric of 25 lake trout per 1,000 feet of graded mesh gill net, 2 to 6 inch, fished sometime in late spring. On a lake-wide basis, the CPUE targets that we set aren't being achieved, but there are some places where these targets are being achieved, mostly in the Illinois waters, MM-5 and MM-6, which I'll show in the next couple of slides, and the Wisconsin waters of WM-5, which are down near the Mid-Lake Refuge, and additionally in the Mid-Lake Refuge. For those of you not familiar with Lake Michigan, the management units are labeled by what state they are adjacent to. Mostly you have MM1, MM2, MM3 taking up most of the northern part of the lake, and MM3 encompasses most of the northern refuge. MM4 encompassing Grand Traverse Bay, MM5, 6, 7, and 8 moving down the Michigan shoreline. Wisconsin has the WM1, 2, and 3 around the Dorp Peninsula, including Green Bay. Most of WM1 and 2 are not sampled very much for lake trout, given that they're fairly shallow water habitats. WM4 moving down the lake, WM5 and 6. And in addition to that is the Illinois and Indiana waters. So those labels will be used throughout the talk, and I'll show this map again a little bit later just for a refresher. And as you can see, there's the Mid-Lake Refuge encompassing some of the Mid-Lake Reef complex that is in the middle of the lake. These are the plots of the LWAP survey that I just alluded to, where the target is the 25 fish per 1,000 feet of graded mesh gill net. As you see, the line of 25 is shown on all these graphs, and this graph shows lake-wide up in the upper left-hand corner, moving over to Illinois, and then proceeding from the northern waters of Lake Michigan from MM3 down south on the western shore of Michigan through MM4, 5, 6, 7, and 8. As you can see, the Illinois waters have, in the past, in the early 2000s, have had a number of years where they achieved the 25 lake trout per 1,000 feet. But in a number of the Michigan waters, that goal has not been achieved. In addition to that, on the last row here, we have WM5, which is down near the Mid-Lake Reef, followed by the Northern Refuge and the Mid-Lake Reef waters. WM5 and the Mid-Lake Reef have shown both times in the recent past where they have achieved this target, but as you can see, a lot of waters in the northern part of the lake are not coming close to achieving the target. The third objective is by 2020 to achieve densities of spawning lake trout in the targeted rehabilitation areas comparable to those in other Great Lakes where lake trout are doing well. The goal of this metric is to have 50 lake trout per 1,000 feet of 4.5 to 6 inch gill net. And as you'll see in the next slide, of the 12 areas sampled last year in fall 2012, only 6 areas met or exceeded that target. And as you can kind of guess, it's the ones where you saw a lot of fish in the previous slide. In some areas, most likely in the north, the abundance of adult fish is low and may not be adequate to result in egg deposition, which would yield enough fish to overcome the impediments of lake trout rehabilitation. This is a graph of the metrics of where spawning surveys were performed. You'll see that as we move from left to right, we are moving from MM-4, which is the Grand Traverse Bay waters, through Illinois in the purple, the southern waters of Wisconsin in orange, the Mid-Lake Refuge in dark orange, and then the fairly tiny numbers of the Northern Refuge in black on the side. Similar trend as to what we saw before. You don't have a whole lot of spawners unless you have quite a few fish. The fourth objective is to, by 2024, have spawning populations in targeted areas stocked prior to 2008 should be at least 25% female and contain 10 or more age groups older than age 7. In places that were stocked after 2008, this should be in place by 2032. The results of this are 7 of the 12 sites sampled in the fall of 2012 exceed the target for female percentage, and the age composition at the time of this talk was not available to put together the metric for the 10 or more age groups. This graph is similar to the previous one. You see the all average here on the right, the MM-4 waters in blue, the Illinois waters in purple, Wisconsin waters in orange, Mid-Lake Refuge in dark orange, and the Northern Refuge in black. One of the concerning facts is that in the MM-4, the Grand Traverse Bay waters, we are seeing that upwards of 60 to 70% of the fish are female, which seems to be fairly skewed towards the females when in fact that usually during most typical surveys you see a lot more male fish just because they're in and they hang around the reefs a lot longer than the females do. Depending on the timing of the survey, you could get a lot of females in the survey just by hitting on the right night when the females came up to spawn. Objective 5 is by 2021 to detect a minimum density of 500 viable eggs with, as Nick pointed out before, of thiamine concentrations greater than 4 nanomoles per gram in previously stocked areas. This should be achieved by 2025 in newly stocked areas. The data I have for this is not the most recent stuff, but as you'll see, the egg deposition rates remained fairly slow from 2000 to 2009, and egg deposition rates are less than 60 eggs per square meter, much further away from the 500 target that we are looking for. As you see here, there's a number of sites: Grand Traverse Bay of Ingalls Point, Elk Rapids, which is also near Grand Traverse Bay, Bay Harbor, and Little Traverse Bay Crib. You'll see that except for this one high value back in 2000, most values have been 50 or less in the recent years. Objective 6 is to have consistent recruitment of wild lake trout in targeted rehabilitation areas as follows. By 2022, detect age 1 fish in bottom trawls. By 2025, detect age 3 fish in spring graded mesh gill net assessments. And by 2028, consistently detect subadults. We do have some more promising results in terms of this. In 2012, 5% of lake trout caught in the LWAP survey, the spring graded mesh survey that I indicated before, were those that had no fin clip, indicating that they were likely naturally reproduced. As you'll see on the next slide, the value in 2012 is the highest in the time series, and this is in relation to a recent paper that the Fish and Wildlife Service out of Green Bay put out. The standard error in marking rate, which would be fish to get out of the hatchery without being marked, would be about 3%. And as you'll see, we've started to increase in the last number of years here to a value which is starting to, as we will hope, to increase throughout time. I'd also like to point out a few other points where to show an increase in lake trout natural reproduction. And Dale reported on this, I think, last year, during February of 2010 and 2011, about 20% of the the juvenile lake trout that we caught in some net sets that we were setting for bloater eggs that were being taken to Ontario resulted in 20% of the juvenile lake trout being unclipped. This is in the waters off of the Mid-Lake Refuge, just south of the Mid-Lake Refuge, and off the Door County Peninsula in the northern waters of Michigan, northern Wisconsin waters of Lake Michigan. In 2012, these bloater efforts were continued, and 14.4% of lake trout off of the Door County Peninsula were unclipped. Recently, in the last couple of months, they've been continuing this effort. In 2013, approximately 22 and 21% of the lake trout that were caught in these nets, and you can see the numbers of total there, were unclipped, sampling off the Door Peninsula and near Manitowoc, Wisconsin. The one other shining star is that results from the fall 2012 spawner surveys in Illinois yielded almost 50% unclipped fish, and this is a fairly substantial sample with 262 unclipped fish out of a total of 528. That's to say, it seems like unclipped fish are doing fairly well in the southern part of the lake. In addition to this, there's also some results from the USGS. In 2010 and 2012, they caught age 0 wild lake trout that were unclipped for the first time since the survey began in 1973. In 2012, this equated to, it's a fairly small sample size, but it's fairly good proportion. 2 of 4 lake trout caught were unclipped. In addition to this, outside the scope of the age zeros, there's since 2005, 18 of 113 lake trout that they've caught in the bottom troll, for a proportion of 16%, have been unclipped. This is in stark contrast to prior to 2005, less than 2% of all lake trout caught in that fall bottom trawl were unclipped. And lastly is Objective 7. This is by 2007, 75% or more of the lake trout in deep and shallow water habitats should be age 10 and younger and of vital origin. And as you've seen from the previous graphs, this is where we're hopefully heading to, but we are far from there. This is just a status summary of the stocking that was done in 2012. As you'll see, the yearling stocking on top was nearly 3 million fish, along with about just over 500,000 fall fingerlings in 2012. As you'll see for the yearlings, a fair number of them were of the Seneca strain, along with a fair-sized chunk in the Michigan waters of Lewis Lake, along with some Klondike Reef fish that went in Wisconsin, and Apostle Island strain that went in Michigan waters. Indiana and Illinois mostly get Seneca Lake with a few other strains thrown in. The fall fingerlings comprised mostly of Lewis Lake strain, along with Seneca Lake, but you also do have this chunk of Perry Sound that went into the Wisconsin waters that will be stocked in greater numbers this fall, or this spring. So for the second part, I'm going to move into the talk that Chuck gave at the AFS meeting last year, talking about lake trout rehabilitation in Lake Michigan. This is kind of it was the way Chuck wanted to do it, and I'm not sure if it's the logical way, but it's the Chuck way. So it's maybe getting the history after the status update. The objectives of this part of the talk are to review the management actions used in Lake Michigan to rehabilitate lake trout from 1965 to 2012, assess the progress towards lake trout rehabilitation over that time period, and draw conclusions from the prognosis made towards what's happening or what's going on with lake trout and how rehabilitation is going forward. In the late 1960s, as I'll show in the next slide, the lake trout population was considered extirpated. This was likely a result mostly of sea lamprey predation and overfishing. Sea lamprey had been gotten into the lakes about 20 years earlier. In response to this, a major stocking program was started fairly soon thereafter in 1965. Over 90% of these lake trout were stocked in nearshore waters, just because I think that was what was available for technology, and that's where anglers are looking for lake trout. Most of these fish were stocked. They were the Superior Marquette strain. In addition to this, there was a number of Green Lake strain, which is a inland deep lake in Wisconsin. And the stocking rate reached 2.5 million yearling equivalents by 1972. There's a conversion rate for fall fingerlings to a yearling equivalent. I think it's 2.4. It's varied over time, but there's a conversion that says fall fingerlings are not going to survive as well as spring yearlings. This went on until 1985 when the implementation of the lake-wide management plan for lake trout was implemented. This saw the establishment of the northern refuge and the southern refuge where fishing is prohibited, trying to provide some sort of refuge for lake trout. The goal of this plan was to maintain annual stocking rates between 2 and 2.8 million yearling equivalents per year, and the movement of moving 50% of these lake trout into offshore stockings into the refuges to give them a better chance to find the place where they likely are going to spawn and maybe have a better chance of surviving. In addition to these changes, they began stocking a number of other strains. The Lewis Lake strain, which is a remnant lake trout or remnant Lake Michigan strain that was taken out to Lewis Lake in Wyoming back in the 1880s, was brought back to Lake Michigan in hopes that it would reestablish itself, along with stocking other Lake Superior strains, the Apostles, and I think one other one. And this was the beginning of the Seneca Lake strain, which it seems like in more recent years has been identified as something that seems to do well in the Great Lakes in light of lamprey predation. The goals of the 1985 Lake-wide Rehabilitation Plan were, by 1995, achieve larger spawning populations in the refuges and high priority zones with an annual survival of at least 60%. By 2000, to routinely catch juveniles and wild lake trout in trawls and gill nets and refuges in the high priority zones where they were thought to survive best. And by 2005, wild spawners should represent a significant portion of the lake trout spawning population in Lake Michigan. As you can see, all these dates are in the past. And in response to that, the Guide for Rehabilitation was drafted up in 2008 by a number of folks here. The message of this was to maintain the northern and southern refuge, to increase annual stocking rates to over 3 million yearling equivalents per year, and to look into stocking a number of other strains that may be able to utilize habitats that aren't being used by the current strains that are being stocked in the lake. This includes the Klondike Reef for the humper strain from Lake Superior, and the Perry Sound strain, which is a nearshore, shallower water habitat strain of lake trout from Lake Huron. Here's a map. I'll just kind of show where a few of these strains have come from. The Apostle Islands come from the Apostle Islands, just in case you don't know where those are, in Lake Superior. Marquette strain came from somewhere around Marquette, as far as I know. The Klondike Reef, or the humper strain, comes from the Klondike Reef, which is actually about 30 miles offshore here in MI7 in eastern Lake Michigan. And the Perry Sound strain comes from Perry Sound, a little inlet here on the eastern shore of Georgian Bay. As you can see, just in relation of how big the refuges are in Lake Michigan in relation to some of the refuges in Lake Huron. We have 6 Fathom Bank and the Drummond Island Refuge here, and the Apostle Island, the few refuges around the Apostle Islands. This is a graph of yearling equivalent Lake Michigan lake trout stocking over the years. As you can see, with the original plan in 1965, you see a ramping up of stocking. They made some considerable numbers back then, somewhere between, leveling off to somewhere between 2 and 2.5 million for a significant part of time. And then in 1985, when the next management plan came into effect, you have some increased numbers, but a little more variability over those years. And in the recent past, we've surpassed 2.5 million with a number of years approaching the 3 million fish target. This is a plot of projected lake trout biomass in kilotons from some work done by Yob Tassé down at the QFC at Michigan State, showing the increase in biomass from the original stockings in 1965, some dips in the late 80s, and then there's a fairly precipitous decline here until the early 2000s where there starts to be an increase. I asked Chuck to kind of pontificate on what the causes of this decline are, and a number of it was the increase here is likely caused by increased sea lamprey control and the implementation of the consent decree, which limited lake trout and whitefish harvest in northern Lake Michigan and some more of the Michigan waters. But it seems like a lot of this decline may have been the result of increased lamprey production in Lake Michigan and possibly some commercial fishing impacts, and possibly recreational lopped on top of the commercial. This is three graphs depicting the Northern Refuge Lake Trout spawner survey that the USGS does on three different reefs. We have Boulder Reef, Gull Island Reef, and Richards Reef. And as you can see, it seemed like they all three of them were doing fairly well until about 2000, when it seems like kind of the bottom fell out of the spawning population. And this has kind of been going on for quite a while. It seems like it's seen in a number of surveys. In the northern part of the lake, we just don't see older fish anymore. And it seems like a lot of this may be due to increased lamprey predation up there. Once fish get to be a spawning size, they just cease to exist because that is one of the preferred target size of sea lamprey. In addition to this, Chuck pointed out that in 1995 there was a change in the stocking guidelines to recognize that fish that were going in were larger, so that less of them need to be stocked. So the implications of this are probably seen in these numbers as less fish are stocked, less of them are making it to the spawner size, and this probably just exacerbates the impact that sea lamprey were having on the population. This is a graph of the Mid-Lake Reef Complex, the southern refuge in Lake Michigan. As you can see, back in time, we did have some higher spawner numbers, but over the last 10 years or so, we have had fairly consistent spawner numbers over both all of Sheboygan, the east, and the northeast reef. I was hoping to update this plot, but I didn't have the source file for it. And I apologize to Mike Hansen and a number of others to this graph. I didn't have this one. I couldn't remake it, and I realized last night that the biggest parts of this plot are red and green. But they do indicate that what we are seeing is a movement from the younger fish, which is in blue here on the bottom of the plot. This is a plot of percentage of composition of the spawning reef populations over time. And as you can see, we're moving a lot more from a predominance of age 5 and younger fish to, as we move through the 90s, we have a lot more 6 to 10. And as you see, age 11 to 15 show up. And then as in the last 5 to 6 years, we have a preponderance of larger fish greater than 15. This is fairly obvious here on Sheboygan. In East Reef, it seems a little less obvious, but we are seeing an increased number of age 15 plus fish, which would indicate that these fish are surviving longer and hopefully contributing more to the spawning population. The next couple of slides I'm going to kind of go over instantaneous mortality rates. These are outputs from the statistical catch and age models that Mark Ebner talked about that we do for the consent decree waters in northern Lake Michigan. This is a plot of all the mortality sources that go into the catch and age models. On the bottom here in black, you'll see natural mortality, which is modeled as a constant over time. In the gray here is commercial harvest. In the kind of small bars in between the white and gray is the recreational harvest, and the white bars on top indicate sea lamprey induced mortality. And as you can see, this is for ages 6 to 11, which would be mostly spawning fish, since we don't see a whole lot over 11 in MM-123. This is all of the management units in the northern part of Lake Michigan are lumped together. So this would include most of the northern refuge and all the waters around the straits and over towards Green Bay. As you can see here, we have a target mortality here of what we consider sustainable. And as you can see, for the last 15 years, we've had mortality which exceeds the sustainable target. And that is likely leading to the decreased populations and spawner abundances that we've been seeing. And if you look at, if you start to parse these out, you'll notice that a lot of these mortalities since the implementation of the consent decree in 2000, after which commercial harvest was ramped down considerably, the thing that's pushing this population over the brink is the significant lamprey mortality, which is being inflicted on these fish. Contrast with that, lake trout ages 6 to 11 from the southern part of the lake, which would be MM-67, which is the far southernmost, not southernmost, but further south waters of the Lake Michigan shoreline, or the state of Michigan shoreline. Here we have a similar natural mortality across the board, with a fairly minor commercial harvest, and you'll see in this zone the recreational harvest is much more substantial. And as you'll see, the implementation of the decree here in 2000 didn't have that much of an impact because of the lack of commercial harvest. But you will see that as these mortalities are far below the target mortality that we implement in the catch and age models, and as you saw in the graphs previous, the lake trout populations in the southern end of the lake, near MM6, 7, which are kind of adjacent to the southern refuge, are doing a lot better than those in the northern part of the lake. Here's another plot of Chuck's numbers from the northern refuge. This is lake trout spawner surveys and the percent unclipped. One thing to note here is that you see these large percentages of unclipped fish in the recent past. These are significant, but you did want me to note that these are smaller sample sizes of approximately 30 fish, and that all these blanks in the past are not just unsampled populations, but it's actual zeros in the data. All of these years from 1991 to the present were sampled, and anything that doesn't have a blue bar indicates that was 0% unclipped observed that year. The line here he has represents the 5%, which was the value we used for the error of fish getting out that were unclipped out of the hatchery, which has now since been refined to more recent times, which for 3%. This is a more in-depth look at the wild fish that were caught in the bloater bycatch surveys that I mentioned earlier. As you'll see here, this is the 2011 Mid-Lake Reef fish. This was the bloater egg take that we took off of the 60 Fathom Bank, which was just south of the Mid-Lake Reef. In 2011, we didn't age the fish, which we remedied in 2012, but as you'll see here, the top plot represents the total fish that were caught. Black fish are the unclipped fish, the red fish black fish are the clipped fish, the red tabs are the unclipped fish. As you'll see, these pink shaded areas follow the unclipped fish that were observed. We have 2 that were over 500 millimeters out here up in the high 500s and one at the low 700s, but what we wanted to point out here is that majority of these unclipped fish happen to fall in the length ranges of a number of their clipped brethren, which represents 2008 through 2005 year class, hypothesizing that many of these unclipped fish probably were of one of these age classes or a number of these age classes. This graph is similar to the previous one, except that in 2012 we took aging structures from the fish and parsed them out to what proportion of the fish that were captured of those year classes represented wild fish, or at least unclipped fish. In the 2010 year class, these would have been 2-year-olds. We represented 60%, fairly small sample size. But as you move a little bit further back in time, you'll see that we still have some fairly substantial proportions of unclipped fish. And what Chuck hypothesizes and wanted me to point out is that the fact that these unclipped age classes seem to fall fairly close to the time that when Dave pointed out here, after alewife populations crashed, after in the early 2000s, alewife took a dive, and we're starting to see these populations from the 2005 and older year classes show up in our not our assessment nets yet, but it seems like they're showing up in a number of other gears that are catching what seem to be smaller fish. This represents what Chuck likes to call the double whammy of alewives on lake trout natural reproduction in the Great Lakes. Kruger et al. Showed that there was alewife predation on young lake trout fry, and O'Gorman's work in Lake Ontario also showed that lake trout didn't pull off year classes until there was a delay in the onshore migration of alewife in Lake Ontario, saying that until some conditions prevented alewife from moving inshore until later in the year, it seemed like lake trout weren't pulling off year classes, which seemed to, hypothesize would give lake trout a chance to get out of the rubble and the cobble, get mobile, and get away from the predation sources coming at them. And Fitzsimmons et al. Did some work showing the relation of the possibility of low levels of thiamine, a direct result of the thiaminase in alewife corresponding to alewife in adult lake trout diets, could lower the survival of egg and fry as they progress. So conclusions and prognosis are that lake trout spawner abundance are at levels high enough to support self-sustaining populations in a number of various locations in Lake Trout or in Lake Michigan, but we still have a fair amount of work to go from there. The target adult lake trout annual survival rate, 60%, is being met at some locations, but a number of those are the locations where the populations are high enough to sustain the population. And despite the the recent evidence of successful lake trout natural reproduction, it's fairly limited, into a number of waters, and we hopefully look forward into the future to see more unclipped lake trout each year as we go out and sample more and see them more in our standardized assessment gears. There's the interference by alewives with lake trout natural reproduction appears to have been and continues to be an impediment, the most impediment to lake trout rehabilitation. Other impediments to point out are low spawner abundance at some locations, inadequate age structure in that spawner population, and other egg and fry predators that have been hypothesized to be having a significant impact on lake trout numbers. And the question on Chuck's mind is whether alewife abundance in Lake Michigan is now low enough to allow lake trout rehabilitation, and whether that, is this the trend that we saw in alewife abundances that can continue to be low. It seems like some of the work that Dave did and showed seems like alewife are not doing the greatest, and maybe this may be a good thing for lake trout. And if it is, what happens in the changing ecosystem? We've seen what happens in Lake Huron, but from there, I know I have a lot of time left. But does anybody have questions? I'll try and answer them. If not, I will defer to others in the room or refer you to Chuck. Mike.